Somewhere in the constellation Canes Venatici, there is an object so heavy that if you dropped our entire Milky Way galaxy into it, all 400 billion stars, all the planets, all the dust and gas, it would barely notice. That is not an exaggeration. That is math. For decades, scientists believed nothing in the universe could get bigger than a few billion times the mass of our sun. Then they started finding objects that broke that limit. Then they broke it again and again. Each time astronomers thought they had found the ceiling, something heavier turned up in the dark. Today, we are ranking the 5 most massive black holes ever measured, not by guesswork, but by the actual data astronomers have pulled from light that in some cases has been traveling toward Earth since before our planet existed. One quick warning before we start counting down: the deeper we go, the stranger the numbers get. By the time we reach number 1, you may find yourself questioning whether big is even the right word anymore. Number 5 on our list is already so massive that human intuition breaks down trying to picture it. Let's start there. In April of 2019, humanity did something that had never been done before. A network of radio telescopes spread across the entire planet, from Antarctica to Hawaii to Spain, worked together as a single Earth-sized instrument. Their target was a galaxy 55 million light-years away called M87. What came back was the first photograph ever taken of a black hole. It looked almost peaceful, a soft, glowing ring of orange light wrapped around a perfect circle of darkness. But that darkness was not empty. It was the edge of an object with a mass of roughly 6.5 billion suns. Here's what makes that number hard to sit with. Our own sun already accounts for 99.8% of all the mass in our solar system. Every planet, every moon, every asteroid combined is a rounding error next to it. Now take 6.5 billion of those suns and compress them into a single point. The black hole at the heart of M87 doesn't just sit quietly either. It fires a jet of superheated particles out into space at nearly the speed of light, a beam so long it stretches for over 4,000 light-years, longer than the distance between us and the center of our own galaxy. Scientists have measured this black hole using 2 completely different methods, one tracking the motion of stars around it, the other imaging its shadow directly, and both landed on nearly the same number. That almost never happens in astronomy. When 2 independent techniques agree this closely, it tells you the measurement is solid. So why is something this massive only 5th on our list? Because what's coming next makes M87 look almost small by comparison, and the black hole in position 4 was hiding in a galaxy so faint, so dim, that astronomers almost missed it entirely. At the center of a galaxy cluster 700 million light-years away sits one of the strangest objects ever observed. The galaxy is called Holmberg 15A, and it doesn't look like it should be hiding anything extraordinary. Its core is unusually dim, fainter than astronomers expected for a galaxy of its size. That faintness turned out to be the clue. When a team using the Very Large Telescope in Chile modeled the motion of stars near the galaxy's center, they found something that initially seemed impossible: a black hole with a mass of around 40 billion suns. At the time, it was one of the most massive black holes ever measured through direct observation of how stars actually move, not estimated from brightness, not inferred from radio signals, but calculated from real stellar orbits. Here's the unsettling part. That dim core isn't a coincidence. Astronomers believe it's a scar. When 2 massive black holes merge, the violence of that collision can fling nearby stars outward, literally scouring the galaxy's center empty. A faint core, in other words, can be a fingerprint left behind by a black hole collision so powerful it rearranged the galaxy around it. But here's where good science does something a lot of documentaries won't tell you. It corrects itself. A more recent analysis, using deeper data from the Keck Observatory in Hawaii, revised that mass estimate down to around 22 billion suns. Still almost 20,000 times heavier than the black hole in the Milky Way. Still one of the most massive ever directly measured. But a reminder that even the biggest numbers in astronomy come with error bars, and those error bars can be enormous. Why does that matter for the rest of this list? Because the next 3 black holes we're about to cover are measured with far less certainty than Holmberg 15A. Their masses come from methods astronomers themselves describe as indirect, educated estimates built on emission lines, radio brightness, and mathematical relationships rather than watching stars orbit in real time, which means the numbers only get shakier from here, and significantly larger. $10.4 billion years ago, in the early universe, a quasar blazed so bright it outshone the combined light of an entire galaxy. We call it Ton 618, and the light from that ancient explosion of energy is only reaching Earth now, meaning the object we're looking at may not even exist in its original form anymore. We're watching a fossil. The black hole believed to power Ton 618 has been measured in 2 very different ways, and the 2 answers disagree by nearly 30 billion solar masses. The original estimate from 2004 put the mass at 66 billion suns, a number so large it once earned Ton 618 a place in the Guinness World Records as the most massive black hole known. A newer analysis from 2019, using a different emission line in the spectrum, revised that figure down to roughly 40.7 billion suns. Even at the lower number, this is still an object whose gravitational reach spans roughly 400 billion kilometers. An event horizon so wide it would swallow our entire solar system and leave room to spare. Light itself cannot climb back out from inside that boundary. Here's a question worth sitting with for a moment. How do you weigh something you can never touch, never visit, and never directly see? Every mass estimate for Ton 618 comes from analyzing how gas swirling near the black hole stretches and shifts the wavelengths of light it emits. Different elements in that gas give different answers. It's a bit like trying to weigh a moving train by listening to how its whistle changes pitch as it passes. Brilliant physics, but never perfectly precise. What we do know for certain is this. Ton 618 is bright enough that its luminosity alone is around 140 trillion times that of our Sun. It is one of the most powerful objects ever detected in the observable universe. And yet, Ton 618 isn't even the largest black hole in its own galaxy cluster class. 2 more candidates on this list may be even heavier. One of them was hiding inside what was once considered the largest galaxy ever discovered. For years, IC1101 held a title that made it famous among astronomers and stargazers alike, the largest known galaxy in the universe. It stretches for roughly 600,000 light years, 6 times wider than the Milky Way, and it sits at the heart of a cluster over 1 billion light years away. A galaxy of that scale needed something equally massive anchoring its core. Estimates for the black hole inside IC1101 have ranged wildly, depending on the method used, from around 40 billion solar masses based on its radio emissions, up to nearly 98 billion solar masses in some later calculations. Let that range sink in for a second. That's not a small disagreement. That's a difference of almost 60 billion suns, an entire Ton 618's worth of uncertainty. This is what makes ranking these objects so difficult and honestly so fascinating. We are not dealing with a settled scoreboard. We are watching the frontier of science happen in real time, where the biggest black hole in the universe title has changed hands multiple times in just the last 2 decades. What isn't in dispute is the scale of IC 1101's gravitational dominance. If a black hole in this mass range sat where our Sun does, its event horizon alone could swallow not just Earth's orbit, not just Jupiter's orbit, but potentially reach out toward where Pluto circles the Sun. Here's a pattern worth noticing before we reach the top of this list. Every single object we've covered so far sits at the center of an enormous galaxy cluster. Places where matter has had 13 billion years to collect, merge, and grow. The bigger the neighborhood astronomers have found, the bigger the monster hiding at its center. Which raises an obvious question. If galaxy clusters keep producing bigger and bigger black holes, what does the single largest cluster in the observable universe contain at its heart? "5.7 billion light-years away lies the Phoenix cluster, one of the most massive, most extreme galaxy clusters ever discovered. It is producing new stars at a rate that shouldn't be possible for a galaxy this old, and at its absolute center sits an object that currently holds the crown as the most massive black hole known to science. Phoenix A star, estimated mass, 100 billion times that of our Sun. To put that number into perspective one final time, 100 billion solar masses is roughly 25,000 times heavier than the black hole at the center of our own Milky Way. If you replaced our Sun with Phoenix A star, its event horizon would stretch out nearly 4,000 astronomical units across, engulfing not just every planet in our solar system, but reaching far beyond where Pluto orbits, out toward the frozen edge of the Oort cloud itself, and it's still growing. Astronomers estimate Phoenix A star is adding roughly 60 more solar masses to itself every single year, fed by one of the most powerful cooling flows of gas ever observed pouring into a galactic core. Here's the part that should genuinely unsettle you. Unlike M87 star, which was measured by directly imaging its shadow, Phoenix A star's mass is inferred, modeled from the extreme behavior of the gas and star formation happening around it. It has never been directly observed the way M87 star was, which means it's entirely possible that somewhere out in the observable universe, hidden in a cluster we haven't studied closely enough yet, something even larger than Phoenix A star is quietly waiting to be found. Some researchers have even proposed a new category entirely for objects that might exceed 100 billion solar masses, something they call stupendously large black holes. Not officially confirmed, not yet observed directly, but mathematically, nothing rules them out, which means this list may not be finished. It may just be the current leaderboard, waiting for the next telescope, the next survey, the next flash of ancient light to rewrite it completely. 5 black holes, a combined mass that adds up to hundreds of billions of suns, hiding at the centers of galaxies most of us will never see with our own eyes. Which one on this list surprised you the most? Drop your pick in the comments below.